So I'm gonna draw some of these coins and try to time it. Watch me. Starting from 1 feet. Go. Okay. 2 feet. 3 feet. 4 feet. 5 feet. 6 feet. 7 feet here. Oh, looks like I lost a pen. Alright, let's rewind for a minute now. You saw that I did an experiment where I dropped the coin from different heights and recorded the time measurement. In your case, you will measure 5 different sets of time for each height, and then you will take the mean, which is average, and the standard deviation, which depicts how spread the data is. Based upon that, we will do some basic analysis. So for us, we did a simple experiment where we dropped the coin from certain height. That height is h, and the time taken to go from here to there is given by t. So we have the height, which is our vertical displacement as it was going down here from different height, and then the time is the time taken when we started the drop and then when it hit the ground, right? So we will do the experiment 5 times. You will do the experiment 5 times and record the time. For example, it could be, let's say, 0. Let me just make up a number here for an example. Let us suppose that you did the experiment 5 times, which is, then you will take the average of that time. That time is important for us. The average hopefully will smooth out any error that may have happened during one of the observations that you did. As a demonstration, I have done this experiment from different heights and have recorded the time for 5 instances of the experiments to smooth out the error that might have happened during the time measurement, especially for lower height, because it is really short time. I have taken the mean here. The standard deviation indicates the spread of the measurement. For example, whether I've been consistent in my measurements as indicated by the standard deviation. And then for the formula, I need to find the time square, because the time square will be on the x-axis. So I'm taking the mean time that came from 5 experiment and then took the square of that. To do that, I simply have to insert the formula. Now I'm going to copy that the height in meter and then the time square value from my calculation spreadsheet and copy it into a new spreadsheet. So this is what happened. I have the height and the time square value from my previous spreadsheet, and I'm going to insert my plot here. It's easy to do that. Go to insert menu, chart, and it is basically simple arrangement here. In the setup, I would set it as a scatter plot. You can see that. And once I have that, this is the y versus x kind of curve here, and I can easily fit this equation. The y-axis should be the height, the x-axis should be the time squared. Since I fixed the axis now, x-axis is time square and the y-axis is the height, I will go and decorate it a little bit. It's easy to do this by going to the customize, insert the trend line, use equation as the label. That's the instruction here on the side. And once you have that, it will show an equation of the fit. And this kind of equation will play important role in deducing some of the scientific data. This is linear regression, by the way. So we have an equation that represented our Coindrop experiment where height is related to time square and it is linear in nature. You can see that. The slope of this line will be equal to half of the acceleration due to gravity, half of g. From there, you can find the acceleration due to gravity by multiplication by 2, which is 9.8 meter per second square.